All right, I thought it might be interesting to go through the 2014 released AP Calculus, now the AB version of AP Calculus, the released exam. I'm going to go through it in a sequence of videos. Like today, I'm going to do 5 questions from the multiple choice section where it's no calculator. So no calculators on any of these. And on all these questions, I'm going to try to move it along and try to sort of think out loud so that you can be noticing the same things I am as I'm working through. Remember, when you take the real exam, you want to keep it moving so that you get through all the questions and you leave plenty of time for the more difficult questions. Okay, let's get to it. So question 1 here, I see an integral. That means I'm going to be doing the antiderivative. I also notice that the upper bound is a variable. So after I do the antiderivative, remember we represent antiderivatives with the capital F typically. We're going to end up plugging x in, and then we're going to also plug 2 in, and we're going to do subtraction. So we do have to do the antiderivative of this here. So let's do that down below. So we're going to do the power rule in reverse. So we add 1 to the exponent, and then we divide by the new number. So 3 divided by 3 is 1 out front. So I'm not even going to bother writing that. So t to the third there. And then the antiderivative of minus 1 or negative 1 is negative t. Okay, and we're going to evaluate that from 2 to x. So this is where I'm going to go ahead and plug the 2 in. We always plug the upper bound first, x to the third minus x. And you see some of those answers up above have that, right? But don't forget, you have to also subtract capital F of 2. 2 plugged into the antiderivative. So here's the antiderivative, so we're going to put 2 in here and here. So that would be 8 minus 2, which is 6. So we're looking for x to the third minus x minus 6, which is right here, answer A. When you take the exam, try not to write more than you need to. Okay, like I probably wouldn't have bothered writing this. I would have just looked for the answer and moved on to the next question. All right, next question. What is the slope of the line tangent? The derivative comes to mind, right? The derivative is that tangent generator to the graph of the function y equals the natural log of 2x, where x equals 4. So we're going to have to find the derivative, and then we're going to plug 4 into that. That's the two-step process. So the derivative of this, again, on the actual AP exam, don't bother rewriting it. That just wastes time. We're going to take the derivative. The derivative of natural log u is 1 over u, so 1 over 2x. But don't forget the chain rule. Some students will. We're going to multiply by the derivative of that. So then what happens is the 2's cancel. We're left with 1 over x. You plug your 4 in, you get a quarter. A quarter is the answer. All right, so that's like a 20-second problem max. All right, you read it, you see the tangent, you see they gave the function, boom, take the derivative, plug 4 in, you're done. Moving on, number 3, look at this problem. What do you see? I see I'm going to need to take the derivative, and I'm going to need to plug 2 in. So it's kind of similar to the last problem, but who knows? Let's see what else is there. All right, so we got to do the power rule here. When we take the derivative, we get negative 8x to the, all right, here's where maybe some students might make a silly mistake. You need to reduce the exponent by 1 when you're taking the derivative. So that means adding negative 1. So it becomes negative 3 plus, okay, so if you multiply by 2 here, you get 2/4 times x, and then the derivative of 4, of course, is just 0. Now we're going to plug 2 in. So if I plug 2 in here and plug 2 in here, I end up getting negative 8 over 8. Why? Because 2 to the negative third is 1/8. So end up getting an 8 in the denominator here, plus 4 over 4. What do you see? This is negative 1. This is positive 1. They add up to 0. The answer is 0. Hopefully you followed my logic there. I think the trick was that negative exponent, all right, when you take the derivative, it becomes negative 3, not negative 1. And then just the plugging in there. All right, 2 more questions lined up here for you. Once again, an antiderivative. We're taking an integral. This is a definite integral. We have bounds. So we have to find the antiderivative first. And this is a 1 over u question where u is 2x plus 1. So we're going to have to do some quick u substitution. So this is the way I always set it up. U equals 2x plus 1, and then I write du equals 2 dx. So therefore dx is the same thing as du over 2. Notice that 2 is in the denominator. So when I rewrite the integral, I could put a 1/2 on the outside. That 1/2 comes from this guy right here, okay? Because I'm putting that in for dx, as you know. Hopefully this is just all review for you and easy peasy. This is 1 over u du, which is 1/2 ln u evaluated from. Now, you're probably wondering, wait, Mr. White, are you going to change the bounds? Yes, I am. Here's our machine that converts from x's to u's. So I have to plug the 1 in there and the 2. So if I plug 1 in, I get 3. If I plug 2 in, I get 5. So evaluated from 3 to 5 is how you say that. This would be 1/2 times the quantity ln 5 minus ln 3. And if I zoom out here, that is option E. That is option E. It was there. All right, one more question for this video, and then I'll just keep chugging along and make subsequent videos with and create a playlist for you so you can go through the entire test. All right. Oh my goodness. So we have a crazy graph, lots of things going on, and I look at this problem and I see they're testing our understanding of one-sided limits as well as regular old limits. So let's just go through it one at a time. The limit as we approach 2 from the left, well, where's 2? Right here. The limit as we approach 2 from the left is f of 2. And I do see that there's a closed circle here. Both of these are -1. We're approaching -1, and when we get there, we're actually at -1. So that's true. What about 6 from the left equaling 6 from the right? Remember, this is one of those tests for whether a limit actually exists there. Does the left equal the right as we approach 6? It sure does. They're both approaching an output of -1. So once again, -1 equals -1. So that's true. And then on this last one, does the limit exist at 6? Well, let's see. Does the left equal the right? Yeah, we just said they're both -1. But wait, what about f of 6? If you go to 6, you end up going down to -3. You end up going down to -3. This equals -3, so this is not one of the options. And fortunately, it looks like option C includes Roman numerals 1 and 2. All right, so hopefully you found this helpful. Check out my playlist where I just continue on. I'll do 6 through 10 next. All right, good luck.